How do self-driving cars work? Imagine a world where you can relax, catch up on your favorite podcasts, or even take a nap while your car drives you to your destination. This isn't a far-off fantasy, it's happening now. Self-driving cars are revolutionizing the future of transportation, eliminating human error, reducing traffic, and changing the way we commute. But how exactly do they work? Today we're pulling back the curtain on the cutting-edge technology that's driving us into the future. Welcome to Infinitia Verity, your go-to place for mind-expanding content on the latest technological innovations and scientific discoveries. In today's video, we're diving deep into the fascinating world of autonomous vehicles and exploring how self-driving cars function. Buckle up, because this is going to be an exciting ride. What are self-driving cars? A self-driving car, also known as an autonomous vehicle, AV, uses a complex system of sensors, cameras, radars, and artificial intelligence, AI, to navigate without human intervention. These vehicles are capable of detecting their environment, processing vast amounts of data, and making decisions in real time. Self-driving cars are often classified into 5 levels based on their automation, ranging from level 0, where the driver controls everything, to level 5, which is complete autonomy with no need for a human behind the wheel. Did you know that while Tesla's Autopilot and GM's Super Cruise are often touted as self-driving, they only operate at level 2 automation? This means the car can handle steering and acceleration, but a human must remain in control at all times. Google's Waymo is currently testing level 4 and level 5 autonomous vehicles where the car can drive without human intervention in most environments. However, level 5 cars, which would have no steering wheel or pedals, are still in the experimental stage. How do self-driving cars sense their environment? The backbone of autonomous vehicle technology is its ability to see the world around it. Self-driving cars rely on several types of sensors, each designed for a different function. Cameras are crucial for visual recognition, such as identifying street signs, lane markings, pedestrians, and other vehicles. Most self-driving cars are equipped with multiple cameras to provide a 360-degree view. Radar systems measure the distance and speed of surrounding objects, helping the car detect other vehicles, especially in bad weather conditions like fog or rain. LiDAR sends out laser pulses to create a detailed three-dimensional map of the car's surroundings. This allows the vehicle to accurately gauge distances and detect obstacles even in complete darkness. Ultrasonic sensors are used for short-range detection and are particularly helpful when parking or detecting obstacles close to the vehicle. Interestingly, Tesla cars do not rely on LiDAR, unlike many other self-driving cars. Tesla's CEO, Elon Musk, believes that with advanced AI and cameras, LiDAR is unnecessary, whereas companies like Waymo and Uber continue to rely on LiDAR technology. LiDAR technology was originally developed for space missions. It was used by NASA to map the surface of the moon during the Apollo missions. How do self-driving cars make decisions? Once the sensors collect data, the car's AI steps in to interpret this information. Machine learning algorithms and neural networks are used to process the data in real time and make driving decisions such as when to turn, accelerate, or brake. This is where deep learning comes into play. By training on vast amounts of data from human drivers, AI systems learn to mimic human driving behavior and respond to different driving conditions. Over time, these systems improve, becoming more accurate and reliable. Self-driving cars need to process up to 1 terabyte of data every hour while on the road. This massive amount of data includes sensor inputs, road conditions, traffic signals, and real-time movements of other vehicles. AI systems in autonomous cars aren't just learning from their own experiences. Companies like Waymo and Tesla use simulated environments where their cars can drive millions of virtual miles, learning new skills and safety features without ever leaving the lab. How do self-driving cars handle safety? One of the biggest questions surrounding self-driving cars is safety. Human error accounts for 94% of all traffic accidents, so the potential for autonomous vehicles to drastically reduce accidents is high. However, the technology is still in its early stages, and several systems are in place to ensure the safety of these vehicles. First, redundancy systems. Self-driving cars often have backup systems for crucial components like braking, steering, and sensors. This ensures that even if one system fails, the car can still operate safely. Second, geofencing. Many self-driving cars operate within restricted geographic areas known as geofences, where the environment has been meticulously mapped. This allows cars to operate more safely in a controlled setting. Third, driver monitoring systems. For vehicles at level 2 and 3 like Tesla's Autopilot, systems are in place to monitor the driver's attention. Cameras inside the car track the driver's head movements and ensure they are ready to take over if needed. Interesting fact, despite their advanced technology, there have been several high-profile accidents involving self-driving cars. This has led to ongoing debates about when and where fully autonomous vehicles should be allowed to operate. Another interesting fact, in some cities like Phoenix, Arizona, Waymo has launched fully autonomous taxis that operate without any human driver, making it the first service of its kind in the world. Challenges facing self-driving cars. While the technology is promising, there are still significant hurdles to overcome. First, weather conditions. Snow, fog, and heavy rain can interfere with the sensors of self-driving cars, making it difficult for them to navigate. Second, ethical dilemmas. How should a self-driving car react in a situation where an accident is unavoidable? Should it prioritize the safety of its passengers or pedestrians? These ethical questions remain a hot topic in the field of autonomous vehicles. Third, regulatory issues. The legal framework for autonomous cars is still evolving. Different countries and even states have different laws regarding their use, creating a complex landscape for manufacturers. Interesting fact, while self-driving cars can handle most driving tasks, they still struggle with unpredictable human behavior such as jaywalking or sudden stops. Another interesting fact, some experts believe that we won't see fully autonomous vehicles level 5 on public roads for another decade, despite the rapid advancements in technology. What does the future hold? The future of self-driving cars is incredibly exciting. As technology continues to evolve, we may see fully autonomous vehicles that can handle any driving situation, from bustling city centers to remote rural roads. Self-driving cars have the potential to revolutionize industries beyond transportation, such as logistics, public transit, and even emergency services. Interesting fact, some experts predict that by 2035, self-driving cars will make up nearly 20% of all vehicles on the road, dramatically reducing traffic and emissions. Another interesting fact, autonomous vehicles could save thousands of lives each year by preventing accidents caused by human error, according to a study by McKinsey & Company. So how do self-driving cars work? It's a combination of highly advanced sensors, artificial intelligence, machine learning, and real-time data processing that makes these vehicles possible. While we're not at full autonomy yet, the future is bright, and self-driving cars are sure to change the way we travel forever. If you found this video informative and exciting, make sure to hit that like button, subscribe to Infinitia Verity, and ring the notification bell so you never miss out on our deep dives into the technology of tomorrow.